Hi everybody. This video is going to be about systems of inequalities and specifically how to solve systems of those linear inequalities. So an inequality and a system of inequalities can each have many solutions. So there can be infinitely many solutions to an inequality and a system of inequalities. So a solution of a system of inequalities is a solution for each inequality in that system. So for example, if you have a system of, say, 2 linear inequalities, your solution is going to work for each inequality. It's going to make the first inequality a true statement and the second inequality a true statement. So, very important that you understand that the solution is the set of all points that are solutions of each inequality in the system. And that system of inequalities can be solved in more than one way. And this video is going to show you how to solve using a table, and we'll do an additional video on how to solve by graphing. And graphing is usually the most appropriate method to solve a system of inequalities because it shows you that infinitely many solutions. When you're solving using a table, you're looking at specifically the whole number solutions or those discrete solutions. So again, inequalities, notice those inequality symbols. That's how you know you got an inequality. It's a mathematical statement that has a less than, greater than, less than or equal to, greater than or equal to system. So let's just go ahead and jump into solving a system using a table. So let me write that down. Solving a system by using a table. And this is where we're going to assume that your x and your y values are whole numbers. So assume that x and y are whole numbers. And I want to know what is the solutions to this system of inequalities. So let's say we have a system of, say, x plus y less than or equal to 6 and negative x plus 4y greater than 8. So that's my system of inequalities. We want to make a table of values of our variables that solve one of the inequalities. So let me go ahead and create that table. And it's just going to be an XY table. Okay. So we've got to choose the whole numbers to start with for our X values. So let's discuss what whole numbers are. Whole numbers are your positive integers and 0. So in other words, you're counting numbers and 0. So 0, 1, 2, 3, 4, 5, 6, and so on. So I'm going to write down 0, 1, 2, 3, 4, 5, 6, 7. We'll just start with those for now. Now, it's important to find the y values that are going to satisfy. So I'm going to kind of do this in 2 steps. I'm going to first use these x values and substitute it into one of the inequalities. A little tip, much easier to substitute it into one that has a less than or equal to, because that'll give you a finite amount of solutions. So I am going to take this x plus y less than or equal to 6, and I am going to substitute in x is 0. When I plug that in, I get 0 plus y less than or equal to 6. Well, that means y is less than or equal to 6. So my solutions for y less than or equal to 6 are all the whole numbers that are less than or equal to 6. So my y values for 0 would be 0, 1, 2, 3, 4, 5, and 6. And now I'm going to go to x equals 1. And I'm going to plug 1 into that inequality. 1 plus y less than or equal to 6. Solving it, y is less than or equal to 5. So that means for x equals 1, I need to list all of the whole numbers that are less than or equal to 5. So 0, 1, 2, 3, 4, and 5. After that, 2 is next. 2 plus y less than or equal to 6. Solve for y. Y is less than or equal to 4. So for x equals 2, I have to list all the whole numbers that are less than or equal to 4. So 0, 1, 2, 3, and 4. All right, got to keep going. X equals 3 is my next value to plug in. 3 plus y less than or equal to 6. So y is less than or equal to 3. So I need to list all of the whole numbers for x equals 3. Y is less than or equal to 3. So that's 0, 1, 2, and 3. So now I'm going to shove in, let's see, x equals 4. So 4 plus y less than or equal to 6. So y is less than or equal to 2. So for x equals 4, I'm going to substitute in I'm going to write out all of the whole numbers that are less than or equal to 2. So 0, 1, and 2. I need to keep substituting. X equals 5. 5 plus y less than or equal to 6. So y is less than or equal to 1. My whole numbers less than or equal to 1 are 0 and 1. X equals 6. 6 plus y less than or equal to 6. So y is less than or equal to 0. So that just gives me 0. But what happens when I substitute in, say, x equals 7? 7 plus y less than or equal to 6. So that means y is less than or equal to -1. Well, there aren't any whole numbers that are less than or equal to -1. So that's when I know I get to stop. Notice you've got a finite number of solutions here. And all of these are solutions to x plus y less than or equal to 6. So for example, 0, 0 works, 0, 1 works, 0, 2 works, and so on. Those would give you all of the whole number solutions that satisfies that x plus y less than or equal to 6. Now to solve a system of inequalities, my solutions have to work in each of them. So over here, I'm going to take that negative x plus 4y greater than 8. And I have to do the same thing. I've got to substitute in x equals 0. So let's see, -0 plus 4y greater than 8, 4y greater than 8, and solving as y is greater than 2. So that means I want to somehow mark all of the whole numbers for x equals 0 out of the list from 0 to 6 that's listed, where the whole numbers are greater than 2. So I'm going to circle 3, 4, 5, and 6. So those are going to be solutions to our system. But I got to keep going. I got to check x equals 1. Plug it into the inequality, -1 plus 4y greater than 8. Let's see, 4y would be greater than 9 when you add 1 to both sides. Y is greater than 9/4. Well, 9/4 is the same as 2 1/4. So for x equals 1, out of those possibilities, I need to circle all of the solutions that are greater than 2 1/4. So 3, 4, and 5 are going to be solutions. Now I've got to check x equals 2. Plugging that into our inequality, -2 plus 4y greater than 8, add 2, divide by 4. 10/4 is the same as 2 1/2. So with x equals 2, I need to circle all the whole number solutions that are greater than 2 1/2. So that's going to be 3, and that's going to be 4. Well, we got to check x equals 3. So I have -3 plus 4y greater than 8. let's see, add 3, that's 4y greater than 11. Divide, that's 11 fourths. 11 fourths is the same as 2 and 3 fourths. So for x equals 3, I have to circle the whole number solutions that are greater than 2 and 3 fourths. Well, that's going to be 3. Well, let's check x equals 4. I'm kind of running out of space here. Negative 4 plus 4y greater than 8. I have 4y is greater than 12. When we add 4 to both sides, y is greater than 3 when I divide by 4. So I look at x equals 4, and I need to circle all of the whole numbers that are greater than 3, and there aren't any. So I have checked all of the solutions and figured out which ones satisfy both x plus y less than or equal to 6 and negative x plus 4y greater than 8, both of the inequalities that are in our system. So now, brings me to this next part, and I got to give myself maybe a little bit of space here. I'll kind of bubble it in a little bit. And these are going to be our solutions. So now that I've got my table, I have to write my solutions, and my solutions are going to be ordered pairs. So looking at our table, everything that is circled is a solution. So it looks like for x equals 0, I have 4 solutions. At x equals 0, I have 0, 3, 0, 4, 0, 5, and 0, 6. Now at x equals 1, it looks like I have 3 of them. At x equals 1, I've got 1, 3, 1, 4, and 1, 5. At 2, it looks like I have 2 of them. So I have the solution 2, 3, and 2, 4. And then at 3, it looks like I have 1 of them, and that would be 3, 3. What that means is the solution 0, 3, when I plug in x equals 0 and x equals 3 into each inequality, both statements are true. So 0, 3 is a solution to our system of inequalities. 0, 4 is a solution. When I plug in x equals 0, y equals 4 into each inequality, it makes each inequality true. Therefore, it's a solution. When I plug in 0, 5, x equals 0, y equals 5 into each inequality, it makes both inequalities true statements. Therefore, 0, 5 is a solution. I can continue and do that with the rest of those solutions, and all of them are going to make each inequality a true statement. Therefore, it would be a solution to that system. So these are all of the whole number solutions to this system of inequalities.